Greetings and welcome to another installment of QuantSlob. This is 16, if you can believe it, in our basic application series. This time around, we're going to take a quick peek at the basics of counting. And when I say counting here, I'm not necessarily talking about 1, 2, 3, 4, although it certainly is quite related. We're actually talking about combinatorics. Combinatorics is all about combinations, the selection of values or objects from within a larger collection. Combinatorics has many, many important applications. Recall back in our probability sampling distributions mini-series, there we looked at a number of different sampling distributions for proportions. Then we did not really spend any time talking about how these sampling distributions were calculated, but it turns out that calculating these sampling distributions relies on combinatorics, and it is with this application in mind that we're going to focus our brief exploration here. So, to illustrate, suppose we have 6 pizza toppings here, and we want to know how many different pizzas we can make with 3 unique toppings from our selection of 6. Certainly, one way to get to our answer is to simply enumerate or count all of the possibilities here. And with a little bit of patience, doing so, we find that there are 20 possible 3-topping pizzas that can be made from 6 available toppings. In the language of combinatorics, we call this scenario 6 choose 3. This is simple shorthand for how many combinations of 3 unique items can be chosen from within 6 unique items. And to illustrate a way to think about solving these sorts of problems more generally, we turn to our good friend Pascal's triangle. And of course, Pascal's triangle is named after the great mathematician and frame welder Cooter Pascal. I suspect that someone is having a little bit of fun at our expense. Our QuantSlob fact checker is out for the week on vacation, but I am quite certain that Pascal's triangle is named after the great 17th century French mathematician Blaise Pascal and not Cooter Pascal, so I apologize for that. So moving on here, back to Pascal's triangle. Let's break this down. What are we looking at here? First thing we notice is that, well, it bears resemblance to a triangle. It's a triangle filled with numbers, or more specifically filled with counting numbers or natural numbers. At the top, we have the number 1 at the pinnacle. Along the right and left sides here, we also see 1s. Once we have the 1s on all the sides here, the 2 sides, all the rest of the numbers can be filled in with simple addition. Notice the 2 here near the top. This value is simply the result of adding the 2 numbers above it, the 2 1s. And this simple pattern holds for all of the non-edge numbers. We have 3 is the result of adding 2 to 1, and 3 plus 3 is 6, and so on. Okay, so what does this have to do with pizza toppings here? Well, to show you, what we're going to do here is we're going to number the rows, but we're going to do this in a very particular way. The very top row, the pinnacle here, we're going to call row 0. Then we're going to count up all the way down the triangle. In this particular example, the graphic here that we have goes down to row number 7. In theory, of course, it keeps going, but this will serve us perfectly fine for this application. Not coincidentally, we're going to focus here on row 6. We'll zoom in on it. We're going to call the leftmost entry here on this row choose none. The next entry, choose 1, and all the way to the rightmost entry, we're going to call choose 6. And so, do you see it? 6 choose 3 right here is 20. This is the result we just derived by counting all of the possibilities. Pascal's triangle provides the answer to how many 3-topping pizzas can be made from 6 available toppings, and how many 2-topping pizzas can be made from 5 available toppings, and so on and so on. And of course, it doesn't just work for pizzas, but a vast variety of problems involving combinations. And there's a more direct way to solve these sorts of problems, and we're going to pick this up in counting 2. And that's it. That's going to do it this time around. Thank you very much for tuning in. I really do appreciate it. And don't forget to stay tuned for more QuantSlob.